1.01 feet. Okay, for number 16, this one did not have a drawing. So here's the river. Okay, here's the tree. Here's someone surveying and measuring, measuring the bearing. So this is north, and this is 22.5 because 30 minutes is half of a degree. So 22.5 degrees east, and then 400 feet down, they took another measurement of bearing. So there's the other north right there, and this time it was 15 degrees west of north. So this is 15 right here, and again measuring the tree. So what I did here is I enlarged the triangle to make it easier, and so that the numbers fit, the angles fit clearly, because this is a big mess right here. So this is 67.30 and this is 75. We're looking for the width of the river, so that would be from here to here. This is 400. So I drew an altitude. Okay, so I added these two angles and I got 37.30, so 37.5 degrees. Why did I do that? Because by finding this, I can now I have opposites. I have the angle and the side opposite, so I could set up a law of sine proportion right here to find A. Okay, so here it is, 400 over sine 37.30 equals A over sine 67.30. Okay, because this angle is opposite this side. So this is what I got for A. Well, knowing A, I could take this as a right triangle and use SOHCAHTOA. So here's my angle, here's the side I'm looking for, and here's the hypotenuse. So that would be sine of 75 is x over A. So this is A. Solve for x here, and here's your final answer. 586.37 feet. Okay. 17 and 18 are very similar. They gave you 3 sides, and so just the numbers are different, but the procedure, if you look at them side to side, they're pretty much the same. So remember, when you're given 3 sides, you look for the largest angle first. So how do you know that? The largest angle is opposite the longest side. So in this case, C was 20, so I looked for angle C first. And so here's the setup. Remember, the angle opposite, the side opposite the angle is always after the negative. Okay, so here are the other 2 measurements, and then this one's here, this one's here. This is what you get as a ratio, inverse cosine of this ratio, and here's your angle. And then I found the second largest one, which was 12. Okay, and opposite 12 was angle B. So same thing. Same formula, just inverse cosine of this ratio gave you this. And for the third angle, all I did was take 180 minus the sum of these 2 angles right here. Okay. For number 18, I have the same thing, just I looked for the longest side, which is 19. That was C, so I'm looking for angle C first. Once I find angle C, I do the second largest, which is 15, and here's it's B, so it's opposite angle B. And here's the setup, you get 45.93. For angle A, you take 180 minus the sum of these 2 angles, and it's 19.60. Okay, so on the test or quiz, this is as much work as I expect you to show. Okay, you not need to set it up and show like this, the numerator, denominator, and then the inverse cosine. Just put it in the calculator and then it gives you this. Okay, for number 19, it's law of cosines, but this time they gave you side angle side. So here's what's given. I did a quick sketch of it right here. Here's the angle 150 degrees. And so I found A first using law of cosines, and it's right here. You can just input this in the calculator as you see it. For me, it's force of habit of like simplifying this part and adding these 2 together and coming to this point. But you could just put it straight into the calculator, and you get A squared equals 846.41, and the number is irrational, it keeps going, right? And then square root of both sides, and then you get this for side A. After that, since now you have opposites, you have this angle and the side opposite, you could set up the law of sines right here. So 29.09, which you just found from this step, over sine 150 equals 10 over sine B. Cross multiply, so you get 10 times sine 150 divided by 2909, and this is the ratio you get. And then inverse sine of this answer, and you get 9.9. For angle C, you add the 150 plus the 9.9 and subtract from 180, and you get this. Okay, so number 20 is similar to number 19. You have side, side, side. You take the longest side, which is B, and so you find that angle first. And so then, since that's the biggest side, like I was saying, you're looking for angle B. So this is side B. This angle has to be opposite. The side opposite this angle has to always be after the negative. And so you plug that into the calculator. This is the ratio you get. Inverse cosine, and there's the angle. Then I look for the next biggest side, which would be side A. So angle A is the next one. And again, law of cosines. Here's the setup. Inverse cosine of this ratio, and you get this. For the third angle, you can just add the two angles that you found, subtract from 180, and you get the third angle. Okay, for number 21, this is now a side angle side. So here's the, just move it up a little bit more. Here's the setup. I sketched it just to to have a visual of the triangle. You find side C first, okay, and again just plug it into the calculator just like you see it, and you get this, and then you take the square root and you get this. Once you have the side, now you have opposites. You use the law of sines here. This rate, when you put this ratio in, you get sine of A, right? So you do the inverse sine to get this angle. And then to get angle B, which is the third piece that you're missing, you just take the given angle plus the one you just found, subtract from 180, and you get angle B. 22, this is another side angle side. Okay, you look for side B. Here's the setup. Put it into the calculator just like you see it, and you get this. Then you take the square root of both sides, and you get this. Set up the law of sines proportion. Okay, here's A over sine A equals 13.38 over sine B equals 18 over sine A. Cross multiply and divide by 13.38 so that you get this ratio. Then you inverse sine of this ratio to get the angle. To get the third angle, same as before, add the given angle with the one you just found, subtract from 180, and you get the third angle, angle C. Number 23, you have a parallelogram. They told you that the diagonals were 10 and 16, so I divide, they bisect each other. So here's 5, 5, and 8, 8, and the angle, they intersect at 28 degrees, so one of the angles is 28. So and they want you to find the lengths of the parallelogram. So here I have a side angle side. So here's the setup. A squared equals this decimal. Take the square root and round it to two places, so you get 4.29. Okay. For B, now I'm looking at this angle. So I had to find the supplement of 28 because that would be this measure right here. Okay, so that's 152. So for side B, everything's the same as side A, except that here the angle is 152, not 28 anymore, right? So this is what you get after you plug this into a calculator, and there's your final answer for B. 24, they gave you this angle out here, and they want you to find this distance, AC. So you have to find the supplement of this angle of 65, because that would be the inside angle, and so that's 115. Okay, so now I have side, angle, side. Here's the setup. Okay, I put it into the calculator just like I saw it, and you get 378,382.6, and it keeps going. Take the square root of that, And there's the final answer for B. Number 25 is Heron's formula. When you know side, 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 this is how you find the area of a triangle. First you find the semi-perimeter. You take these three, add them together, divide by 2. And so that's 8.5. And then so you take the square root of S, and then the difference between the side, each side, and the semi-perimeter. So minus A, minus B, minus C. And here's the difference. Multiply those four together and you get this number. Take the square root, and so it's 7.64. Remember, it's area, so it's square units.